consider that. We want to thank you for coming. Are there any new people here tonight? Anyone new that hadn't been to a meeting yet?
I don't think so.
Candace has one.
Call me out. I was at the trade show. Tom and Candace from the Sun was coming, but he didn't.
I thought I had one. Thought I had one on the hook.
So we are just going to say, if anybody's new, wanted to introduce themselves, they're welcome to do that. We have time. Steve, you wanted to?
Just if you enjoyed our program in November where we talked about the location and siting of this project, tonight we're talking about the skin of the building. Next month we're going to talk about the frame, the interior frame. Here's a spoiler alert, we're going to use metal studs. But Daryl's going to give us a great argument tonight for block. And Gypsum will be here next month to talk about that, and we'll also talk about fire ratings and fire resistance for the openings. And then the month after that we'll talk about specifically about the elevator that we're going to put in this building. And the month after that in May we're going to barbecue and we're going to talk to estimators. And they're going to tell us what we have to value engineer out of the project.
All right, and then Michael has a couple things he would like to talk about, and then are you also going to introduce the panel?
Yeah.
Okay,
We'll do that. So I'm Michael Bird. I'm principal at Core 10 Architecture, past president last year. Past president, I had a couple of things that did not get checked off my list of things to do at the award ceremony if you were there, because a couple of people couldn't make it. So I tried to get it done in November when we had the first of our panel discussions, and those people couldn't make it then either. But you know, they found their way here. So Mike Lewis, a special president's commendation from the no longer president, for special service as membership chair. Your enthusiasm for and dedication to our members and the future growth of our membership is inspirational and lays a strong foundation for our future.
Awesome, thank you.
Thank you very much. Oh yeah, oh, we got it.
You were very presidential, Michael.
Yeah.
Yeah.
It hasn't worn off yet.
Thank you.
And then one more, Mark Walkenbach, for Special Services Programs Chair. Your enthusiasm and commitment to the core function of our chapter quality programs, even though you're not doing the work and we are tonight. It's inspirational.
For about 4 years I've been doing it.
Provides us a guide for creating more value for our members for years to come. So thank you very much.
Thank you, Mark.
Okay. Now, last November, the panel discussion was an introduction to our project that we'll describe here and catch everybody up on. I was the architect in that panel discussion. It's been explained to me that I've since moved on, that the owner has hired me to be the owner's rep, so I'm going to pretend to be the owner. And our very own President-elect Joel Kirshen is going to be the architect who is leading this discussion and walking us through how designers tackle these sorts of preliminary problems. Now, we've done this over the course of November to February. In reality, this probably doesn't take that long, right?
Not usually.
Okay. So don't read too much into the timing here. But I did want to take a minute and introduce the panel. So thank you very much for joining us. On my left and screen closest to the screen is Daryl McMillian, Technical Director of Masonry Institute of St. Louis. Surely everybody knows everybody on that panel, but in case you don't, Daryl is a civil engineer by education, which I was surprised to find out. And
not so civil.
Well, you don't seem like a civil engineer. And is currently a professor.
Yeah, I teach a masonry course for S&T.
For S&T, absolutely, okay. And you spent many years as not only an educator but also an estimator and an engineer as well. So thank you very much for sharing your expertise. And then we have Karina Moore, sales representative with Luna and Associates. Graduate of Lindenwood University, many years representing Carlisle Syntec. Currently on the board of the Building Enclosure Council. Thank you very much for joining us. And last but not least, Joel Kirshen, president-elect of the chapter, currently senior project manager, it says, senior project manager and specifier with KAI Design Build. So you're overqualified, really. You've been doing this for a lot longer than I thought. When I looked you up, the theme of the panel is a lot. I mean, you've been around longer than it looks like you've been around. All of you look, like you're kind of right. I mean, you look like you're still learning stuff. But really, you've been doing it quite a long time. Joel spent, we won't say how many years with Coleman Design Group, a graduate of KU, and now finally with KI. So thank you very much for leading our discussion here and being the architect. So with that, here's our AIA. We do offer some AIA credit. So thank you, George Everding, for helping us with that, as you do every month. And with that, Joel, I'll turn it over to you.
Okay, so as we said, in this ever-changing world, the project architect that previously was working on this job left, and went off to the owner's side of the equation. And so now I have picked up this project, and so I'm learning about this project as we go too. So the idea is that there's a existing building in downtown St. Louis that wanting to put a elevator onto, right? So, as it said, they're tired of walking up and down stairs, 6-story building. It's an office, it's going to stay an office. They just want to add some vertical circulation to it. So, earlier on, the team looked at the project, tried to determine, some of the parameters. So the geotech work came back saying that, there wasn't anything really outstanding there that looked like it was going to be a problem. No great soil conditions or excessive groundwater involved. Now there's bits of old foundations by there and a ramp. We're actually in that photo, right where you see the wall next to the street, we're actually between the wall and the building. So there's an old depressed, which I think was a loading dock area down there that we're going to be going into. All right. So track down some old drawings, get an idea of what the structure was. You can see that they used to have I think a rail car access in there, and looked at the structure, and that there's nothing that's going to cause us a great deal of problem there with the structural and the foundations. At the time, we had talked about going to a steel frame with metal stud skin. That was just the preliminary discussion on it. And then at the time, we also had a contractor looking at it, and they determined that it can be built, it's feasible, and actually all of this we determined for free, at least from the architect's point of view, in terms of paying consultants. Everybody was willing to get a little time, talk to some specialty people, and get this information put together. The other thing that we talked about was that a product representative told us that we're going to have some smoke control on the elevators. Because of the height of the building, the elevator lobbies would have to be separated. But instead of having to build a full lobby with a set of doors on it, there is some other products out there that can be used to shield off the elevator shaft and the elevator opening directly. So that helps keep our project budget down and keeps the footprint down on things. And then the owner did figure out that this project is gonna cost some money and time, but it is still necessary.
That's why he hired me.
And so it's gonna cost him even more money because he hired an architect with his part of his rep. So we did some conceptual studies on the building. The thoughts under consideration, there is just a simple shaft going up the side of the building. There's an existing opening there. It's one of the window openings. So we're gonna take up that opening with, most of the opening with the shaft. There'll be some additional brickwork we'll have to do to infill. One of the question comes into how high are we taking this elevator? Are we gonna go to the 5th floor and stop it? Or are we gonna take it up to the penthouse area? And if we don't take it to the penthouse area, what does that mean to the project and to access to the penthouse? The elevator shaft itself, you can see by the small plan there, it is a very simple shaft. There's nothing else to it except the elevator shaft itself. So, all the fine print, but this is the preliminary project description that we developed in our discussions last time. Alright, so talks about the summary of what we want to do, the fact that they're going to be in the building while this is going on, that there's been some space allocated on the side of the building for all this. We went through some basic code questions there. We did some survey and assessment of existing conditions, get an idea, can the building accept that. We did subsurface work. Got some input on the soil conditions. We're staying pretty conservative with our bearing capacities at this point. And so now, moving forward, we're going to start coming up out of the ground with substructure. So, let's start at the bottom, work our way up, talking about foundations. So what are we doing for foundations and how are we doing it? Then we'll move into the subgrade, slab zone grade, the pits, and then into the shell of the building, the superstructure, the enclosures, and then the horizontal enclosure at the roof. So, looking at the pits and bases, one of the questions that came up, an elevator is going to require a pit that's going to be down below finished floor line. There's no stormwater there, or no groundwater issues that we've identified. So then that brings the question of, what do we need to protect the walls and the slab? So do we need under slab protection? And then how are we protecting the pit itself? Now, we have reached out to a product rep that has a lot of ideas there and experience.
Do I need this?
Do we need this? Can we, Mike, are you recording? Do we need this for the recording?
Let's try without.
Okay.
If you're more comfortable, then definitely.
That's fine.
So, normally, if you've got an elevator pit that is the lowest point of your building, it's typically the smallest little area. So you have to, as an owner, you have to ask yourself, what if water gets in there? Is it worth it to you to do a blindside waterproofing? And if you're not familiar with what that means, blindside is actually, if you're in a water table, that's a no-brainer. Because blindside is when water is actually coming up. So when you're dealing with a blindside application, you would actually put your waterproofing on the mud slab or your rock or whatever, and then you pour your concrete over the top of that blindside waterproofing. And again, it's from keeping it from coming up. I personally have known owners that skip that on their elevator pits and regret it later, because if you get water in an elevator pit, the only way to really help the issue is with injections. And a lot of times with injections, you're just moving the water from here to here. So I always recommend to owners to, even if you're not in a water table, to go ahead and put blindside underneath your elevator pit. But again, that would be something that, I don't know what the budget is and things like that. So
As little as possible.
Huh?
As So as little as possible.
And you know what, everybody forgets that when they have water in their elevator pit, but that's okay.
But I don't have water in my other elevator pit.
So, and again, that's not every owner does it, but it's typically a pretty, low-end insurance policy, if you will, to go ahead and waterproof your elevator pit. So now we've talked about the horizontal, now we go to the vertical. Yes, go ahead.
Would a sump pit work?
Yes, I mean, that is, again, another insurance policy, so again, you just have to ask yourself, if water gets in there, are you okay with that method? So, you know, it's pretty much on a job-by-job basis, but again, it's typically such a small area to waterproof. What's more important, you know, having something that's dry or spending whatever amount that money is. So then we move into the walls. One of the things that there's a big miscommunication or misnomer is the difference between damp proofing and waterproofing. Damp proofing, all damp proofing is for is to keep the soil moisture out. That's it. It doesn't mean that you're gonna have a dry elevator pit or a foundation for that matter. That's typically a 10 mil product. There's no warranties involved with it, things like that. Then you get into a waterproofing system, and a waterproofing system, now you start talking about, you know, 40, 60, 120 mils thick with a drain board, possibly insulation, whatever. So they're two totally different things. The only time that I personally would recommend damp proofing is on a retaining wall. But if you're wanting to keep something dry, damp proofing is not your product. It's waterproofing. So just so we know the differences between the two. So if the owner or the architect chose to go with a blind side underneath your elevator pit, you would then encapsulate that entire elevator pit with your positive side waterproofing and your blind side waterproofing underneath the pit. So your entire pit would be encapsulated with a waterproofing product. So it's a big tie-in detail. It's truly important with something like that. So, is that all I have on that?
Yeah, well, let's, so we talked about, you know, the application, and that's where the labor concerns is who's putting it up, the quality control of damp proofing versus waterproofing. Is, you know, all too often damp proofing is somebody out there just rolling something onto a wall.
Correct. That's about as thick as a piece of paper.
Right.
That's about 10 mils. Yeah.
Right.
Mm-hmm.
And so, as opposed to someone who's a little more trained and has a warranted product, that they're responsible.
Correct.
So you've got.
And waterproofers will do damp proofing too, don't get me wrong.
Right.
But it's just a totally different reasoning why you would be doing damp proofing versus waterproofing.
Right.
Yeah.
Okay. So, as we were talking through this, the other thing that came up is, what are we making the foundation out of? And so, you know, we're going to do cast in place, or, you know, it's not a large area. Do we go to a masonry? So we reached out to our friendly neighborhood masonry expert to so Daryl, what about a masonry foundation at this point?
Yeah, that's certainly an option. You know, the mason can work off of the slab or whatever you're using at the bottom of the pit.
Okay.
And, you know, they can just work that block up and then transition to, if you wanted block above grade, they could just transition to that as well.
So if we're going full height of block, in that case, that wall would just start at the top of your slab, top of footings, and then just start coming up at that point.
Yeah. So, you know, the design of the foundation would change a little bit, because if you have a steel frame, I'm assuming.
You have point
columns,
loads, right?
Yeah. So that foundation's different than if you do a masonry where you can spread that out. Maybe get by with more of a spread footing on the perimeter than, you know, maybe some piers or something to offset those columns.
Okay.
You know, having to work.
All right.
And the masonry probably would be fully grouted and reinforced. So at the end of the day, you're very, very similar to a, you know, a concrete approach, and then that could be damp proof, waterproof, whatever the case may be.
Now, just continue all the way up and become the shell for become the structure for the
Right.
whole addition there.
Right. I mean, you might transition on block size perhaps
Okay.
as you go up, if that's, works well for the design, but yeah, the outside face would certainly be just as smooth.
Well, and we're still looking at a brick veneer on the outside. So, yeah, it'd be natural to transition from a wider block, and then when we go to a narrower
Become a
block,
ledge.
yeah,
Yeah.
we'd have a brick ledge there,
Yeah.
and just work up from there. Now, would the CMU versus concrete have any impact on the type of waterproofing you want to use?
It would just need to be fully grouted, and I probably would recommend on blocks of the fluid as opposed to a sheet.
Okay.
I think it would adhere better to the block as opposed to a poured concrete foundation.
Okay.
Yeah, that's good. That's fair.
All right. So, that yes.
Just a quick question. I know the answer, but, since this is such a small area, could the mason do the concrete pour of the slab instead of having another trade come out and do have another concrete flatwork company come out and do the
Yeah,
basement?
I think that's possible. I think that would be doable if you want to single source that, with the mason, once it's been designed and detailed. Now they may sub that out themselves, but at least you maybe have a little more single source control if you want to look at it that way.
He does the steel studs as well.
What was that?
Go do the steel studs as well. Why not?
Now he's the general contractor. Okay. And so then that'll be something that we'll have to reach back out to a contractor or an estimator when we start looking at the impact on the cost.
Sure.
Where we start looking at, because there's obviously pros and cons, with because if you do a CMU structure all the way up, there's no structural steel involved anymore, right? And the footing and foundation will change around some. So there's going to be pros and cons to not only the cost but also the timeline involved with this.
The fact that Michael's working for the owner, do we have a construction manager? Or just an advisor?
No, I'm the closest thing you've got.
But are we looking to hire a general contractor to do this, or are we trying to contract it out ourselves? Since we also may know something.
We assume we're hiring a general contractor, and my owner's brother-in-law is in the steel stud business, so do with that what you will. I'm just laying it out there. I don't want to tell you how to do your job.
That could be stiff competition.
I'm just saying.
It's not public work, correct?
It's not public work. There's nothing public about it.
But Joel, to your point about cost, most of our larger contractors these days are using virtual 3D estimating, and they could throw that in their computer pretty quickly, and most of them are willing to, just interact in the preliminary phase and just shoot some pricing back and forth, and so you can get to a decision point.
Okay.
Hey Joel, as the architect, the great thing is I'm taking your notes for you and I'm writing the PPD, which ties in perfectly with the estimating software for the contractor.
Good.
What about insulation on the pit foundation?
So that's the question. Do we need insulation on the pit? And if so, how do we get it? So what is your thoughts on how we would get it? I mean, the need may come down to a code issue that we'd have to get into, and that'll be a code discussion on not only just the pit, but also the entire shaft. But we're going to assume that we've got to insulate the basic shaft at this point.
It could be an input point for the elevator manufacturer too as well, right?
Yes.
Depending on what you decide to do with the pit overall.
Well, no matter what substrate you go with, you can always put your waterproofing, I'll just say waterproofing since that would be my suggestion. Waterproofing, then your insulation, and then a drain board on outboard. We do that all the time. There is a big question about you've ever seen the drain board, it's, typically like an 1/8 inch thick, and it's got a fabric on one side and drainage, holes in the middle, if you will. There's always a question, what is the correct layers? Do we do waterproofing, insulation, and then your drain board? Or is it waterproofing, drain board, and then your insulation? There's really no right or wrong answer to that, but just something to think about when you're doing it where you have your waterproofing and then your drain board and then your insulation. If you're using an XPS or an EPS, that's a hard substrate, so the water can have a hard time getting to the drain board because we've now blocked it off with the insulation. So depending upon the rain, you could have a very, wet substrate around that building or elevator pit. So we suggest putting it outboard. But again, it's not like it won't be warranted the other way, but just food for thought. I can tell you that comes up at every single job site that I go to. So, just food for thought. But yes, it's very easy to insulate.
So what other considerations if this job is in downtown St. Louis versus if the job was up on the
Yeah, and I don't know what's going around, the actual elevator pit, if it's sidewalks or something like that, you're right, it'd be irrelevant. But if it were, plants and trees or a lot of greenery and there's a lot of rain that, could come in that area, then again, it's not a deal breaker, but it's just something to think about when you're specifying that. Yep.
Does the insulation factor in the protection of the waterproofing for backfill?
It does a little bit, but when you're dealing with your drain board, that's also a protection layer. Because the way the drain board is made, it has a protection layer on the outside already. So, again, that's pretty much the architect's call, or the owner's call, but it's just, again, something to keep in mind. But the drain board acts as a protection too.
Move up.
So, alright, so in the last session, we talked about seismic. We talked about the fact at that time that a steel frame could work for this, and we can manage all the new loads in the steel frame, and they won't negatively affect the existing structure, and there's no significantly bad soil conditions to contend with there. So once we get the foundations out of the way, we'll get back to a good soil condition. Inside our new building, as we're here, really there's no floors. There's only a slab on grade at the bottom. Because it's just a big elevator, it's just a shaft all the way up, so there's be no floor construction in there. On the roof, though, we will need a roof. It'll be just a metal deck roof is what we're anticipating right now. Low slope, nothing unusual there going on. We'll need to be insulated.
Yeah.
Right?
We'll talk more about that in a minute.
We'll talk more about that when we start talking about the horizontal membrane, horizontal enclosure. So, looking at the exterior walls. So, from the PPR before, we figured out that, the new construction has to comply with IBC for fire protection. We can separate, we can achieve some of that fire and smoke separation with a curtain product, which will avoid the elevator lobbies. That is, focus of that product is smoke management. So, that'll help us there. The thermal resistance of the building, the idea is we're gonna, design this new structure, this new shaft to meet the minimum R values without having to go in and upgrade the entire structure. So, how do we achieve that? Some different ideas that were kicked around. You can do a spray foam, do a mineral wool. There's other hard boards or insulation board products, I'll say. So, what's going to be the best choice there? And we think that starts to tie into the next comment too, talking about any sort of vapor fluid barrier that's going to be on the outside. Because all these are gonna start to play together. So, you know, we have a conversation going then about, air barrier versus vapor barrier.
Well, you can have air and vapor barriers with one product. I will back up when, air barriers were, coming out, it was typically asphalt. And asphalt works as a very, very good non-permeable vapor barrier. But the other problem with asphalt in a wall configuration is it also burns very well. So when you're dealing with, wall construction, you're basically dealing with a chimney, basically outside of your building construction. So if you, and I'm seeing this more and more, where I'm seeing that, there is an asphalt-based air barrier, and with a polyiso or an extruded or something like that, you're not going to pass the NFPA 285, the fire code for the wall assembly, using an asphalt-based air barrier with a combustible insulation. So again, I'm just saying that because I'm seeing it more and more, which kind of surprises me because NFPA 285 has been out for a long time. But if you're using a combustible insulation, no matter what height your building is, you have to meet NFPA 285. If you guys aren't familiar with that test, it's not a single product test, it's a wall assembly test. So that entire wall assembly has to pass. So you can get into some pretty big issues if you're not going to pass that test. So as far as vapor permeable versus non-permeable, we handle both. Most manufacturers do. For me, it's something to be said to let that wall breathe. And again, this is just an elevator pit, but in a lot of instances, if you're dealing with just say a building like this, and you have an outside wall where you're using a non-permeable vapor barrier on, you could actually create water in that wall or condensation in that wall by hanging even a picture too close to that outside wall, or using vinyl wallpapering, or some sort of a paint that's also non-permeable. You can actually trap moisture in that wall cavity. So it's just something, again, to be kind of cognizant about. So the vapor permeable is, again, we handle both, but especially in the St. Louis area, the vapor permeable is something that I typically, it's a go-to because it's a little safer than a non-permeable product. It doesn't allow air movement back and forth through the wall. So, and I don't know if we want to talk about it now, the fluid versus the sheet.
No, I think that does become the question, because that's going to tie into that and the insulation product itself.
Well, I get asked that a lot, you know, do we do fluid or do we do sheet? You know, again, there's both. And there's pros and cons to both. One of the things that is, you do not get a choice is if you have a block wall. If you have a block wall, you have to do fluid. You cannot do a sheet on a block wall. It's next to impossible because that CMU is going to absorb the solvents that will hold up that sheet. There's usually a lot of brick ties, so how do you manage those? So fluid applied on a block wall is definitely the way to go. Speaking of block can be very, very different. Some of the blocks, and we talked about this when we sat down and referred to this, but some of the block is very loose, if you will. So you can get a lot of the air barrier inside the block, and you're not getting your true continuous air barrier if it's soaking up in the block. A lot of the contractors don't know what they're up against when they're bidding. So I always recommend to bid 110 mils or something, because you don't know how porous that block is going to be. So then we go to sheet. So let's just say we have a sheathing job. You can still use fluid. I'd say if there's a negative, the negative is that your sub is determining your thickness. He's on the job site. The low bidder isn't always the best. And I don't mean that in a negative way, but it's just, the guy is determining your thickness. When you're dealing with the sheet applied, the manufacturer is determining the melt thickness of your sheet. But with sheet, you have seams, and with fluid, you don't. You have monolithic. So there's pros and cons to both.
So, I like my brother.
Okay.
My owner likes his brother, but he doesn't quite trust his brother. So, Daryl, if there's money to be saved, I probably want to hear about it by doing something other than steel studs. So, do you want to talk about that?
Yeah, I think the elevator shaft approach here is a little bit different, but normal building construction, if you utilize the CMU as your load-bearing envelope, then you can eliminate your perimeter steel needs.
Mhm.
I think that would apply also to this elevator shaft, because you could build the whole thing out of the block, and the analysis on that from an engineering standpoint would probably, you would analyze the whole thing at once, okay, to make sure that it was adequate, at least to determine block width and rebar size and all that. And in general, what we've seen is that the money that it takes to provide a load-bearing frame for steel steel stud infill is you can find some savings a lot of times by using the load-bearing masonry, the CMU.
Okay. We want to talk about labor too, about the different trades that are on the job, and how they interact, given one approach versus the other.
Yeah, well, and so, if it's block work, you basically got one trade doing most of that work. Now, one of the things they have to coordinate with is the waterproofing, because they put up the CMU, the barrier installer will come in and put on the barrier, and then when it comes to the insulation, I think the mason will put that up as he's putting up the brick, the veneer product, right?
Right.
So you've got two people on site, two trades on site at that point. Now, if we look at a metal stud assembly, you're going to have the carpenters putting up the metal studs and the drywall. Then you're going to have the people putting up the air barrier. Then you're going to have the mason coming in. Now, in that case, once again, the mason, can put up the insulation even in that situation, or are they going to need to, defer that to the carpenters and then come in after the carpenters?
Well, I mean, if you go with a rigid that goes between the brick ties,
Right.
the brick anchors, then that's probably something the mason would do as they bring the brick up.
Okay.
That's what I always do too.
Yeah.
All right.
I mean, there may be some options to that, but I would say that's probably the most common. And the scaffolding the mason is using these days, the motorized scaffolding, they can go up and down all they need. There's no longer they have to build the scaffolding as you go, and the desire to build it only once. All right.
Okay.
So once they get their climbing mast in place, those are left, and then they just go up and down as they need. So
Okay.
it's pretty handy. And I would just also throw out there that you're also gaining, a very, very good fire resistance.
Mm-hmm.
If you take an 8-inch unit and you fully grout it, you've got a 4-hour wall there, just by default. So.
Right. Right.
Okay.
So one of the questions is going to be, then, what kind of insulation do we want to put on here? Are we putting in an insulated panel? Are we putting on a spray-on product? So what are some of our options for an insulation board in a cavity like this?
Well, you have mineral wool. There's pros and cons to all of them too. You have mineral wool. Mineral wool, your R value per inch is going to be less than the others. You have an EPS, so an expanded polystyrene, which is that white beadboard. You have XPS, which is the extruded polystyrene, and then you have polyiso. So the spray foam, I don't know of anybody in town that does spray foam anymore. We used to have one contractor that did it. And the jobs that I've been involved with is out-of-town guys coming in. The one thing that I've seen on job sites, I can tell you some GCs are done with it just because everything there can't be any wind, it has to be a certain temperature. If you're calling out for a certain thickness, you'll get it in some areas, but less than others. So it's a true art to be able to spray that foam. So I don't know why we don't have guys here in St. Louis that do it, but we don't. So that's just the truth of that. So the mineral wool, one of the advantages of mineral wool is your fire code. So you can easily meet NFPA 285 285 using mineral wool. However, again, your wall cavity is gonna have to be wider because of your R value. EPS, it's, also the R value is 5, no, I think it's less than that, it's probably 4, isn't it? Kevin? 4 per inch. The extruded is typically 5, and then your polyiso, you can get up to 6.5 R value per inch. So it's how wide you want that wall cavity to be. You know, polyiso is the best bang for your buck as far as keeping that wall cavity, thinner than using the other products. But yes, there's a lot of options out there.
So how does the polyiso, factor into the, NFPA 285 discussion?
That's a good question. You would have to use, a synthetic air barrier. You could not use asphalt. You cannot use asphalt with extruded, expanded, or polyiso.
Okay.
So you have to make sure that entire wall assembly will meet NFPA 285. So again, it's the entire wall assembly, but typically with a synthetic type of an air barrier, not an asphaltic, but synthetic, you'll be able to pass that test with most of the cladding out there.
So the corners and the details of that air barrier become critical, because that barrier folds into openings, it seals at the top, it seals at the bottom, it seals at all other flashing and penetrations. So what kind of issues am I going to run into with how that has to seal in some of the other products that you end up seeing?
Comparing what to what?
Well, so do all these different products work well together when it comes to air barriers and sealants?
Well, the sealants, the rule of thumb with sealants is that silicone is its own animal. Silicone's a great sealant, don't get me wrong, but the only thing that sticks to silicone is silicone. So with that being said, you can't have a silicone underneath an air barrier, it's not gonna stick. So you have to look at your product data sheets from the manufacturers to see what sealants they recommend to both go under or over the air barrier. You know, as far as sheet versus fluid, there's details for all of those on how you do that. This is a different scenario with this elevator pit. There's no windows, I'm sure, but you're dealing with a building with windows. Something you do have to take into account when you're dealing with a sheet applied air barrier is your window openings. There's a lot of detailing. You can actually build that up to where if your windows are ordered before the job starts, the windows may not fit in that opening if you decided to detail that with a sheet applied. So again, something to think about and you can mix and match. You can do, you know, sheet on the entire job and fluid around the perimeter, around the window openings or the, you know, pipes or whatever that may be.
Okay.
But as far as the insulations go, they work well with all the insulations. So
Okay.
that's really no detailing.
Now, how are these installations just wedged in between the anchors in this case? Are they?
They
Do you
are.
have positive anchorage, or?
Typically, they are wedged in between the anchors.
Okay.
But again, continuous is the big deal now, where we need to be taping those, even though you have an air barrier. It's just another defense mechanism to keep that inside air in and the outside air out.
Okay.
And I've seen a lot of jobs where that's not being done. So that's something that the specifiers really need to make sure your details are correct on that.
Okay. Okay.
Move on to the outside.
Yes. So the existing building has, you know, it was built in, what was the age of the building? The late 1800s?
Late 1800s, I think, 1880.
Yeah, late 1800s. So a lot of historic brickwork on that building, a lot of masonry issues. I mean, it's a very rich building with its detailing. But then that brings in a host of issues that we have to think about now. You know, so there's you have matching issues. How do you blend in? Do you get a custom brick? Daryl, help. What do we do?
So, yeah, that's always the trick, right? When you're adding to an old building or otherwise altering an older building. You know, your brick manufacturers can be a big help, and your brick suppliers. I know on our building over on South Big Bend, when we added on the larger education space, That was by far the best architect I ever worked with, Steve. Anyway, Steve and everybody over at Arc Images at the time worked with Richards, and they didn't have the exact brick anymore. They didn't actually make that brick anymore, but they were able to go through all the brick they're making and pull together a blend that was very, very close. And we were also fortunate that the addition was not next to the original brick exactly. There's a little bit of a separation, so I think it worked really well. You can do a special brick. I mean, there is some lead time to that, maybe even some cost. If you're using one of the brick manufacturer's regular molding process, then maybe you're just changing clay material and clay colors and things like that. But it would be a process you'd have to go through to determine how close you're able to get to the brick, because the brick itself doesn't look like it did when it was installed. And it doesn't look the same all around the building anymore. So you just kind of have to work your way through that, and probably several mock-up panels, and till you kind of hone it down to what you want to do.
You got a question, Becky?
Are you talking about the city historic people during this meeting and their input into what the brick is going to look like, or is that for a later meeting?
It is for a later meeting. I think when I left the project, we were talking about it and we knew we had to have a meeting. But part of that decision, I think, is going to be a value decision on how we want to approach what we're going to suggest to the city and see what we can make fly.
The approach was to come up with a fairly solid solution that we wanted to use, and then take that to the city and say, this is how we're going to solve the problem, solve the issue. And try to control is probably a strong word, but try to mitigate the situation by coming in with a strong approach to begin with.
There is an element of it's better to.
You rely on owner politics on that.
No. The owner doesn't want to do it at all. So the less contact with the city, the better, as far as the owner's concerned.
But I think in general, if your approach is to try to match as close as possible, that's also going to serve you well when you talk about the historic side of it, right?
Well, and then one of the options that was talked about was staining.
Mm-hmm.
So that is a little more labor intensive. Can be a more labor intensive process, but you are. My experience has been you're dealing with. In good cases, you're dealing with an artisan who basically can come in and replicate, and match things very close. Buildings where there was an addition built, the city didn't like the match, so we hired somebody to come in and stain to get the right modeling and the right blend to match the existing building. There was a fee, but
I thought we had a shoestring budget.
well, so it gets relative. What are you going to pay as much to get a custom brick blend done as you would, and wait longer to get a custom brick blend versus having someone come in and put a stain on this.
Would another approach be like with the art museum, a very modern tie-on, so that it offset
Contrast.
Yeah. Would that be another approach as opposed to?
That is.
Like hot pink brick or something?
Yeah.
That is. There's that's a design. That's a decision that we have to have conversations with the owner about, because you can get pushed back depending on the building and what you're doing from the historic side of life. So some areas they're more willing to accept, that modern or that contrasting addition than others.
Memphis has a brick look now too.
Ooh.
Yeah.
Here, I'll get that back on your
We'll offer you
So yeah, that actually
It's a
would
fine product.
solve, exterior insulation, and a few other issues that would be addressed all together.
We'll take care of the whole works with it.
Yeah.
It's sort of a brick-ish look.
So it makes me a little sad to think that we need to get rid of part of this big amazing cornice up here. I mean, that's a lot of masonry up there. I mean, it's already a solid brick wall, right?
Right, so that
Plus,
is-
you add all this.
that's what we determined, was it a 4 white wall?
At
Base
least
wall?
down here, and then once we get up here, look at all the extra stuff we've got to deal with.
So how much can we corbel out in when you're using typical veneer rules? What are our options for corbelling for that? What are our limitations?
So, it's gonna be very difficult to replicate that corbelling of that brick, or I should say for the mason to be able to do it just by their own skill.
Right.
So,
I'm going to try and pull something up that you
I think I brought it.
gave me here. There we go.
Detail. Yeah. So this is from TMS 402, which is the masonry code. And here in 5.5 it talks about corbels. And it says you can either have your engineer design your corbels for you, but you have to if they're load bearing, which these aren't. But or you can detail to the is it 5.5.2? I'm having a little trouble.
Yes.
And so these are the old rule of thumb corbelling rules that the mason used to use to do that very same corbelling back in the day. Where it gets difficult is, and they haven't changed that much, but what gets difficult is when you go to a veneer and you have an air cavity. So if you go down to the next page, Michael.
Mm-hmm.
So this is out of the commentary. You can see the top one there. That's more like the system that's in place. It's solid brick walls. The mason had a lot of options of just scooting some brick out, and it was all structural and held itself together. They would turn brick into the wall, like we call headers, and that would become one system. And there were some, I think it's, let's see, like 1/2 of the unit thickness, or 1/2 of the unit height, et cetera, how much they could go per step. And so they would just work their way through that and accommodate whatever shape, they were trying to get. So now if you come down to a veneer situation like we have these days, and this is showing a CMU backup, but this would be true also for steel stud backup. You have the same rules for stepping out, but if you notice at the very top, it says your airspace, specified airspace, plus another 1 inch. That's all you get. Okay. So if you're going to try to do that profile that's existing now, that airspace is going to get too wide for these rules of thumb. So that would kick you back over to having an engineer look at this whole system and provide some support from the backup for whatever you want to do with that brick out there.
Okay.
Whether that's building in, stepping out if you use steel stud to step that out, maybe with some angles that's catching the brick here and there so they can connect to it. Or if it's a CMU, maybe growing that out a little bit to give you some support, some backup support.
Yeah, so you're to do this nowadays, we'd be back into like you said, it's an engineered detail at that point. Possibly involving some steel angles, other things to help.
Specialized anchors, perhaps.
Yeah.
Maybe, I think we discussed a little bit, maybe some prefabrication of some of that profile. The mason be able to build some of it in pieces and with anchorage built into that, and so that can be hooked on to whatever the engineer comes up with the backup support.
Yeah, so if you think about it, you assemble this in sections, hoist it into place, set it on the wall, and then tie it back as the engineer's going to direct you. Some tie back points that you're going to just do some very hard tiebacks too.
Would you conceivably prefabricate the masonry along with its supporting structure, and then set that entire piece on top? If you're just talking about the cornice.
Yeah, we are starting to see some prefabrication of CMU. The units are put together with the mortar, and then you have temporary rods that go through that are anchored at the bottom until they're set in place, and so they're just like setting sections as you go up. I suspect that the very top could be, done differently to try to accommodate some sort of a corbelling up there.
Now, the big question is that the approach you would recommend?
Usually prefabrication, is more ideal where you've got a lot of area that that's where your economies come, because like if you have a long, tall wall, if they can prefabricate sections of that can be done off-site. It can be done faster as far as setting. This is the scope of this project is pretty small compared to some of the projects I've seen where they've used prefabrication on it.
But the guy probably win an award if they did a really good job, right?
Yeah, we probably put it in our magazine.
Yeah, see?
But I was thinking more in terms of once it's engineered, how you're going to support that brick out there. Perhaps some ingenuity could be, used to maybe prefabbing some of that brick work, for the very top part.
Yeah, that's what I was anticipating too, is you'd almost have a steel frame assembly that you would then infill with brick, and then you'd lift that whole assembly up and set it in place. Right.
Well, I'll tell you, the owner's a traditionalist, so I think we're going to have to deal with this in a as cost-effective a way as possible.
Right.
So are you gonna continue that sill or water table, whatever it is?
Well, that's the decision we need to make here, is trying to figure out what the impact of this, trying to replicate some of these details is going to be on the cost is part of my problem.
No, it's actually brick up there.
Yeah.
This
business here.
That's terracotta. So.
Oh, yeah, there's some additional detailing there that we'd have to,
Come back next month.
That's smaller that, could be wrapped around as a water table using stone and some either special shapes or some projection to get the lower one in. I think everybody was probably looking up to the top, and what do we do with the major arch?
Yeah, you bring up a good point, yeah.
Or do we take the more surgical approach of we're going to just cut and slide the addition in between, right? We'll demolish out a piece, almost like this, and it'd look a lot like this. When you look at it, that corbelling would come up to each side of the addition and just stop.
Or if we want to keep that existing detail, is it worth considering this?
Or do you want to consider the window detail on the outside of the shaft wall?
So in a brick veneer scenario, once again we're back to the corbelling rules and some of those rules of how much relief we can get in there. But there are some special, we could start to turn header courses in that project out, that still have the back of the brick is fully supported, and the face of the brick projects out further, and create some detailing like that on the face to help, replicate some of that. Although part of the trick is our shaft is not the same size as the window. Right? Is one of the things that we have to think about is on the inside, we're going to have a rated partition there, right, separating the old window opening from the shaft. going into a 4-wide wall, so we're gonna have a lot of depth to deal with. So how do we go about that? You know, are we, I know that from the elevator point of view, you're very limited to the amount of shelf you can have on the inside of an elevator shaft. So that means I'm gonna have to have something there on the inside, that, and so that wall, putting a single stud in line with the outside, the interior of the space is not gonna work. So, you know, in a masonry situation, you know, do we go back to a multi-wide wall to infill that opening? You know, and then what is the inside face of the wall at this point? And
So
what will it be?
What you're saying is the new elevator shaft is not as wide as the original window?
It's not quite as wide, but then also the window opening, you know, we'll have to, the elevator door is only gonna take up a small portion of that.
Okay.
And we got the whole area around it, that will have to be a rated wall to separate our shaft from our interior space. And so how do we build that piece?
So, and then the other question is if we want to keep this big corbel, is it worth considering making the shaft shorter and putting a lift to get to the penthouse?
Before you leave the cornice, what if you were gonna just, since it's out of reach of any, people who would like to poke it, and it's far enough away that you really can't see it that well, maybe that's a neatest construction up there. It looks like a corbel, but it's lightweight.
Yeah, or fiberglass or something like that. All right.
Some lightweight replica.
Does that offend anybody in the room?
Well, this is not a theme park,
Would cultural resources buy off on it is the bigger
well, if it
question.
looks good, I bet they would take care of it.
Maybe so. Let's move on to talk a little bit about the roof, and then we'll wrap up.
So, you know, there's the rainwater on the roof. So, we're anticipating with the tall shaft, we're just going to have a roof assembly. I think you may know a little bit about some roof products.
I do. I mean, the square footage of this is pretty minimal. So, I personally like EPDM, 60 mil fully adhered EPDM. I'm assuming you'll have to meet your code R30, so 2 layers of 2.6 insulation of fully adhered EPDM. Since you have a metal deck, you can fasten into the metal deck, and pretty simple.
Okay. And then, because it is such a small area, the idea was we can just do a gutter and downspout system that can spill the water right onto the existing roof. Obviously, we'd have to coordinate where that hits the roof, look at the existing roof to make sure we're not causing problems with having a little bit more dynamic water flow in a given spot. So it gets a little more interesting if we look at a shorter roof. I think the roof assembly stays the same. I mean, I don't see any need to do anything really different there. But then now we don't have an adjacent roof to spill onto. So what do we do with the water at that point? You know, roof drain, scupper and downspout. You know, those are things that we can talk about. One issue with the roof drain that we probably run into is elevator inspectors are notoriously possessive about their shafts. They don't want anything in their shaft except their stuff. So the odds of them letting us run a roof drain down inside that shaft is not very good. So a simpler approach, you know, or another approach would be, do we do, you know, just a simple scupper and downspout assembly on the outside of the shaft in the corner. That also becomes part of a historic conversation because cultural resources will probably have opinions about that, because it'll be a 70-foot downspout running down the outside of the building. They'll probably probably want it to be copper. The owner probably will not want it to be copper.
Nope, don't want it to be copper. It just gets stolen.
Yeah. And then what do we do with it at the bottom? So that's something that we have to look at options there. That's in an old truck well area. We need to look and see if there's some drains around there that we can either tie into directly, or is it in a low enough traffic area that we can just spill. I mean, it is just a 8x10 area of roof, so it's a fairly nominal sized roof. Can we get away just spilling on grade down here? That'll be some conversations we'll have to have with the authorities.
Yeah. So I think we got our work cut out for us now.
Seems like we keep coming up with more questions.
We have more questions than we did when we started. Steve, have you been working on your preliminary project description?
I've got a lot of notes that we need to talk to the owner about and see what kind of decisions they want to make.
I was afraid you were going to say that.
So next month we'll have to we'll meet with the owner between now and then, and we'll come up with the decisions they make, and we'll show you the results of that PPD, and get a printout for you for next month of what the decisions have been made to date.
Yeah, and I anticipate we might even talk about the actual elevator.
No, not the elevator, not yet.
Oh, it's too soon?
It's too soon, because the owner's probably leaning towards metal studs and gypsum. We got to hear about that.
When do we start writing specs? I mean, there's a lot of specifiers in here.
You make those decisions yet. Got to make some decisions as the owner first.
All right. Well, this is a very frustrating process, but
So
So
spec
the
writing.
side was all nice and easy.
Very real world.
yeah. Well, thank you very much to the panel. I've got a few announcements I want to help make here.
Yeah, I was just gonna say, Karina, one thing is we talked about in DEC is tie-in of the roof air barrier to the waterproofing is very critical. Compatible materials and making sure that that is done, or having a line completely down through there. So it's just something to point out, because it's a lot of times it's not thought about. You look at them separate.
And you're absolutely right, Kevin. So, again, I'm seeing a lot. I was just on a job site this week, as a matter of fact, where, years ago we were just worried about keeping water out of the building. Now we're worried about energy efficiency too, which is why we're having to tie our wall air barrier into our roofing system. So I'm still seeing details where we have the roofing here and the air barrier here, not this, and we need this. So when we're doing this, compatibility is a big deal. I talked earlier about silicone. We sell PVC roofing too, but nothing sticks to PVC. So if you have a PVC roof, now we need to talk about how we're going to tie that air barrier into that PVC roof. Or Kevin and I were on a job, I think it was last year, Kevin, where there was a Firestone modified roof and one of our air barriers, and we don't play well together. So what we ended up
Karina and I do.
What we ended up having to do is we used a stainless steel separator, which sounds very expensive, but it's not. There's some, York and Home and Menard make some that is basically a 3 mil thick stainless steel. I happen to bring a sample with me if anybody's interested. It's out on that table just so you can get a visual about what we're talking about with a stainless steel separator. So, but yeah, you're absolutely right, Kevin. Those tie-ins are very important.
Well, that becomes that also is real critical in an addition scenario like this, where we may be tying into an old roof that may be an old 4-ply built up roof or something like that, or a modified bit roof. Those ties, some of these new synthetic products, we need to have that conversation about how all this connects together to get that seamless barrier all the way around.
Right, and then the other misnomer is, and Kevin, I'm sure you get this too, is that a lot of different trades think that we've tested our material with every other material out in the market. That's not the case. I mean, there's just too many air barrier guys coming out in the market. We can't keep up with it, to be honest. So sometimes we do adhesion tests, which are extremely simple to do, but that's where you need to contact your local rep or whatever to do a simple adhesion test, and also to look at the data sheet for what we're tying into. A lot of PVCs have plasticizers that may leach out over time. You might get an adhesion that day, but in 6 months it may become unadhered. So yeah, there's a lot. It's a lot different today than what it was 20 years ago, for sure.
Okay.
So the building was built a century ago, but it was rehabbed,
10 years ago.
5 years ago?
10 years ago.
And how's the air barrier in that wall?
In the existing wall,
Yeah.
there is no air barrier in the existing wall. It's 4 inches, 4 wide of brick.
It's mass.
Because the bricks exposed in on the inside too?
Yes.
Yeah.
Pretty good, this is continuous, so can you get
Right.
a waiver to not have to comply with energy
Yeah,
codes?
we have some questions for the city now.
Yeah.
Yeah,
Because it does absolutely no good unless you have a continuous.
but Ralph Wafer's my guy, so he'll help me out. It's gonna be fun.
I have 2 questions that I want to ask Karina and Daryl, and it's for everyone's benefit really. If I decide I want to do that masonry parapet, can I call you, Daryl, and ask your suggestions and recommendations on who to talk to, maybe to see if we get that done?
From a construction standpoint?
Constructability or design standpoint, can you help us steer us in the right direction to get us the help we would need?
Yeah,
You
sure.
want to do that?
Yeah. Be glad to do that.
And then you guys were just mentioning, Corinne, you and your hemorrhoid over here.
That's the best thing you called me.
Well, you guys will help architects detail those components, correct? The tie-ins between the roof and the air barrier and the waterproofing and the below grade.
Yep.
Will you be able to help take care of that? Because we don't know all that stuff.
Right.
We should. We act like we do, but we should help pass it
Yeah,
out.
absolutely.
Okay.
And I will also say pre-construction meetings are huge for reasons like we're talking about. You can't just think it's gonna work out on the job site. You gotta have a pre-construction meeting and talk about those other trades.
We should probably specify a pre-construction
Absolutely,
meeting
absolutely, yeah.
with the building enclosure specification.
Yeah.
All right.
Good idea.
Daryl, Karina, Joel, thank you very much. Really quick, stlewiscsi.org is where you go to find out everything that we're up to. This is what it looks like right now. You'll see a program, you'll see another program coming up in March. And then in April, this is the most important thing we've got on this page probably right now is the new product show. Kelly talked a little bit about it. You can go here and register to attend. It's free to attend, but we do ask that you register. Please pass it around to everybody at your firms who you think could benefit. We do provide lunch, we do provide CEUs, and there are still just a few tables left. So you'll find a map of what's available and who's already signed up if you go to the website. The next thing we wanted to mention is we're going to start making better use of our LinkedIn company page. Maybe as a better way to communicate with our professional members and associates, maybe better than Facebook, which we used to have a lot of traffic on, and better than Twitter, which is a little exclusionary sometimes, but LinkedIn seems to probably be a better avenue for us. So please go, if you haven't already, and follow us. If you're a member of our LinkedIn group, that's awesome. It is not the same thing. The the LinkedIn company page is a newer feature. It allows us to do a few more things to reach out in a more public way than the group feature does. So we ask that you do go and follow the company page here at this link, and there's a link on stlewiscsi.org. This is what you'll find if you're interested in the product show, and come up to any one of us with a big fancy name tag on, and we'll tell you anything you need to know about that. And with that, here's everybody's contact information if you want to ask follow-up questions. And thank you very much for coming.
And we'll allow if anybody wants to stick around and ask a few questions, you do that. And thanks for coming.
Please leave your